As we get started, I want to review a couple things with you. First of all, I want to review the quadratic formula, which you should have used in your homework. Let's say it together, class. X equals negative b plus or minus the square root of b squared minus 4ac all over 2a. Trust you have that down pretty well. The key to using it, make sure you get your quadratic equation in proper form so you can identify a, b, and c. It's super stupid easy. But it's the student who decides it's so stupid easy I don't need to get it in that form, this finds a way to screw it up. So get it in the form, then let it be stupid easy to get your A, B, and C. Be careful with the math. You've got a calculator to help you with it and get your answers there. This b squared minus 4ac, the radicand here, we call class our... It's on the chalkboard. Discriminant. And there's 4 qualifications, 4 things you can tell just by looking at the discriminant. You can tell about the roots you are going to get for x. First of all, if it's negative, it's less than 0. Can you take the square root of a negative, class? No, at least not with what we call real numbers. It's what we call imaginary numbers, which we're going to get to after your test on Thursday. So we're going to say that your roots would be imaginary roots anytime the discriminant is negative. If it's a 0, then basically this whole thing just disappears, goes away. It ain't there, right? Vanishes. And so you're really just left with negative b over 2a, which seems like one answer. In fact, the book says you get one answer, but we know that a quadratic always gives 2. So if it's 2, but it looks like 1, we would say that the roots are coincident. They coincide. 5 and 5. It's 2 answers. They just coincide with each other. But they would be real. They would definitely be rational. After all, you get them from a fraction. And it would be coincident. If you get a value that's bigger than 0, so you actually get a positive value in here, but it's a perfect square. Well, if it's a perfect square, then you can take the square root, right? And it would come out rational. So you would now have your 2 rational roots again, but they would be distinct as opposed to coincident. The only way you end up with irrational roots would be if this isn't a perfect square. It'd have to be positive, but not a perfect square. Well, then, of course, you're going to have irrational values that you might be able to reduce, but that's it. And you were asked about those things in homework, page 98 in your textbooks. Page 98 in your textbooks. And let's see how we did. I'm actually going to look at the 37 to 42, the second half first. Let's look at the second half of the homework, numbers 37 to 42, and then we'll go back and we'll look at numbers 35 and 36. But I want to go over the first several while this is still up on the chalkboard, so I don't have to rewrite it again because, lazy. All right, so number 37, if the discriminant, b squared minus 4ac, is 11, what do we know about our roots? Brandon?
2 real irrational distinct roots.
Good. 2 real irrational distinct roots. Number 38. What if the discriminant is 121? Abby?
2 real irrational distinct roots.
Good. 2 real rational distinct roots. What about number 39? What if the discriminant is 0, Audrey?
2 real rational coincident roots.
Good. 2 real rational coincident roots. Number 40, what if it's 14, Maddie?
2 real rational something.
The 2 real irrational roots. They will be distinct as well. What about number 41? If b squared minus 4ac, that discriminant is 64. Genesis?
2 real irrational distinct roots.
Are they going to be irrational? Can I take the square root of 64? Yeah, so that's a perfect square, so they will be rational distinct roots here. Whereas, for instance, on number 40, Genesis, you can't take the square root of 14. That's not a perfect square. That's where we get the irrational roots. What about number 42? If the discriminant is 32, what do we get? Kendall?
2 real irrational distinct roots.
Good. 2 real irrational distinct roots. Now, you could reduce the square root of the 32, right? You'll reduce that down into 4 square root of 2, but you still can't get a rational value from it. Questions on those 6? Anyone go 6 for 6? All right, if you didn't, I'm not terribly upset because we were supposed to practice it in class. This ended up being your practice. So does it make sense now how to interpret based on this? Because again, the chart isn't going to be in front of you. And frankly, I don't even so much want you to memorize this, kind of see the pattern. You can't take the square root of a negative. That's imaginary. If it's a 0, that's the weird one. That's where they're coincident. Okay, there's 2. will be real, they'll be rational, but they're coincident. Perfect squares, they're no longer coincident, they're distinct, but they're still rational at least. It's when you don't get a perfect square, they're now irrational. Still two real distinct roots. So all three of these, it's two, it's real. The only one that's irrational is not perfect square. These two are both rational. This one's the only one that's coincident, is the 0. The other two are distinct. So kind of a pattern to memorizing these. Questions on 37 to 42 before we look at 35 and 36. All right, well, let's take a look at 35 and 36 then and see what we got when we solved these quadratic equations. Again, technically, you can solve incomplete quadratic equations. You just have a b value of 0. So you don't plug anything in here and you don't plug anything in there because it's 0. But again, why would you want to? So much easier to simply isolate the squared variable and take the square root. But technically you could. Usable for all quadratic equations. Number 35, they've already got it in the proper quadratic form for you. So all you have to do is list out A, B, and C. Michael?
A is -5, B is 6, and C is 8.
If you wanted to, you could distribute a negative through so you don't have a first term negative. But is that really necessary? Well, I don't know that it frankly is worth it, to be honest. I mean, yes, you know you're going to get a negative denominator, so you'll have to divide negatives here, but otherwise I don't know that it's a huge problem. If you're factoring, you don't want the negative. I'm not factoring. I'm doing it this way. So we're going to be good to go. Class, let's say the quadratic formula together, but instead of x, let's start with w. Say it with me. W equals negative b plus or minus the square root of b squared minus 4ac all over 2a. And we're going to plug in the numbers in for the negative b, Abby.
-6.
Plus or minus the square root of b squared. We're going to put
36.
minus, and then it says 4ac. What is 4 times a times c?
160.
Negative 160. But we have minus a negative. So class, basically just make it a plus or a positive. All over 2a, which will become, Brandon?
Oh, 10.
Negative 10. All right, so we've got negative 6 plus or minus the square root of, what does this radicand become, Maddie? 196. And, well, what is the square root of 196? That's rational, right? This is you're going to get two real, rational, distinct roots. Audrey?
14.
14. So negative 6 plus or minus 14 all over negative 10. By the way, this means we're not going to have to worry too much about canceling away negatives and such. I was hoping to show that, but maybe we'll get another chance. So here, we just simplify the numerator. This numerator, negative 6 plus 14 Genesis, becomes?
-8 over.
Well, keep the sign of the greater. Oh, I see what you did. Okay, yeah. Initially 8 over negative 10, but then we could pull the negative out. Let's also reduce at the same time.
4/5.
Negative 4/5. And then if we put the negative 6, negative 14, that becomes?
-2 over 1.
Right, negative 20 over negative 10. And then here, because we have negative over negative, it becomes positive. And we could just say 2. And there's my two answers, negative 4/5 and 2. How many have these two answers, negative 4/5 and 2? All right, questions on this? Again, this method always works. I don't think it's the fastest. So again, the danger in using this exclusively would be you don't finish a quiz or a test. And that's, that's not good. But it is there. So if you're working a problem, like, I just can't figure it out, just go to this. Use this method and get it correct, or come back to it last and then use this method. Let's take a look at number 36, and I don't want to write number 36 down. There's a much better way to do this, Kendall.
Think of all 3.
Let's divide a 3 out of everything. Not factor out a 3, actually divide a 3. Are we allowed to divide a number away from everything, class?
Yes.
What about a letter? Can we divide a letter away from everything? No. You could factor out a letter, but if you divide it away, you're going to lose an answer. So we can divide a 3, though, to get what, Kendall?
6 m squared, -9m, -1.
All equal to 0. Again, do not divide a letter out, but a number is fine to divide because you're also dividing it from the 0. It just happens to still be 0. So that we can recognize our A, B, and C. And what do we get for the A, B, and C, Kendall?
6, -9, -1.
Good. Make sure you keep track of the signs, as did Kendall. So we were finding M, and M is equal to, say it with me, class, negative b plus or minus the square root of b squared minus 4ac all over 2a. YouTube students, make sure you're saying it also. And in for the negative b, Michael, we'll plug in
9.
positive 9. You don't have to write the positive. Plus or minus the square root of in for b squared, Brandon.
81.
Then minus 4 times a times c, Audrey, gives us
Negative 24.
negative 24 all over 2a, Maddie. 12. Of course, the minus negative again is going to become a plus or a positive. And 81 plus 24, anyone?
195.
81 plus 24?
105.
105. So we end up with 9 plus or minus the square root of 105 all over 12. I'm looking at 105. I'm like, there's got to be a way to reduce it. Let's think. 4 go in? No. Last two just 9? 16, no, because 4 didn't work. 25? 36, no. 49? And the next number's too big, so I guess we have to leave it that way. There's nothing we can do to reduce it unless we did something wrong, and nope, that is the correct answer. Or those are, I should say, the correct answers. 9 plus the square root of 105 over 12, 9 minus the square root of 105 over 12. That's slightly annoying when it doesn't reduce. How many got these answers for number 36? All right, how many had a 3 in everything? And so you had 27 plus or minus the square root of, let's see, that would be, goodness, 945 all over 36 perhaps? Anyone have that? All right, it's not wrong, but here, because this factors in 9 times 105, this could become 27 plus or minus 3 times the square root of 105 all over 36. And you knock a 3 out to get 9, 3 out to get 1 square root of 105, and a 3 out to get 12. So this answer isn't wrong, it's just not finished reducing. Make sense? All right, questions on that? Anyone not get either of those answers, and we need help? All right. Let's turn over to page 105 now. Page 105. 105. You did 14 to 22, the even numbered problems. And number 14, straightforward quadratic, does not factor. You can tell that just by looking at it, hopefully. Also doesn't simplify because you can't divide a 3 out of everything. What did you get for your answer on number 14? Audrey?
Negative 6 plus or minus the square root of 39 over 3.
Good. Negative 6 plus or minus the square root of 39 all over 3. How many had that same answer on 14? Ooh, okay, not as many of us. Hopefully, again, we identified A is 3, B is 12, C is negative 1. Check your work. Did you get a negative 1 or did we write 1? All right, so when we plug it in, negative 12 plus or minus the square root of 144 minus 4 times A times C becomes a negative 12 right here. And that's going to add the inverse there. All over 2A is a 6. Gives us negative 12 plus or minus the square root of 156 all over 6. Did anyone have that answer? I have that answer. All right, because we can, for anyone have a 132 right here? All right, so we just forgot about the negative when we weren't careful with signs. All right, here, 156. 4 maybe? 4 times what? 39. All right, to get negative 12 plus or minus 2 times the square root of 39 all over 6. Anyone leave it this way? All right, so that's where you two left it. And then do you see there's a 2, 2, and 2? And if you knock it out, there's your negative 6. There's a 1 square root of 39. And there's a 3. And that's how we kind of end up with that last answer. All right, so again, not wrong, just, and you even did this step. You even reduced it, just the last step of reducing the fraction itself. All right, good. Questions on this? All right, number 16. And what did you get for your answers there, Michael?
I got negative 2/5 and negative 1.
Mm-hmm. How many also had negative 2/5 and negative 1 for your answers? All right, Abby, what were your answers?
Negative 7 plus or minus the square root of 89 over 10.
Okay. What was A?
I kind of did it in my head.
What is A?
I think
A
she
is
added
5,
5, B is,
7,
C is.
2,
So negative 7 plus or minus the square root of 49 minus,
89. Oh.
you wrote an 8, no, 49 minus 4AC becomes a 40. but they're all positives. 4 times 5 is 20 times 2 is 40, but it's a minus all of that. So that's where you got your 89. Should have subtracted to get a 9, which becomes a rational 3.
Okay.
So just be careful with the sign on that all over 10. And that's where we get negative 10 tenths if we go with the negatives, and negative 4 tenths if we go across the top of the positive 3. There's our negative 1, there's our negative 2 fifths. All right, questions 14, 16. I think Abby was the only one who had a question on 16, and we're good to go now. All right, looking at number 18. What kind of answers will we get if the discriminant is a 36? Well, think about it, class. What do I do to the discriminant? I take the square root. Can I take the square root of 36 evenly? Then my answers are going to be, what's the key word? Rational. They're going to be rational. Now, are they going to be coincident? No, that only happens with a 0. So they're going to be rational, but they're also going to be distinct. How many am I going to have? 2. And if they're rational, that means they have to be real numbers. So 2 real, rational, distinct roots. Do you see how to think through it? Look at number 18. The discriminant is 0. That's the weird one. That's where my answers are. What's the key word to remember? Coincident. Because there's nothing up here at all. Just the negative b over 2a, which means my answer is a fraction, which means it is rational. We already said coincident roots. How many, of course? 2, though it's going to look like 1 because they're the same number both times. And then if they're rational, that means, again, they have to be real. Make sense? Okay, questions on that. 2 real...
Were you on 18 or 20?
20. Did I say 18?
Yeah, you said 18.
Oh, I'd already done 18, so I had moved on to 20. I guess I said 18 a second time for some reason. My Algebra 1 test the other day had 2 number 17s and no number 16. So it's just, that's how I roll. 2 number 18s, no number 20. Let's go to 22, now that we're done with 18 twice. Number 22, 15. Again, what do I have to do to the discriminant class? Can I take the square root of 15? So my answers I already know are going to be, what's the key word? Irrational. They're still going to be 2 of them, right? And of course, irrational and rational numbers are all real numbers. The only ones that aren't real are the imaginary, and that would be a negative number there. But, again, since there's a positive and a negative, that's going to make them distinct from each other. So 2 real, irrational, distinct roots. Questions on 18, 20, and 22. All right, do we feel like we're understanding how to think them through now without having to look at a list of rules, just thinking them through? Page 95, I want you to do 37 to 40. Page 95, 37 to 40. Do not look back at your notes. Try to figure these things out without the notes now. Again, practicing with the discriminant and interpreting the results that would be obtained as a result of said discriminant. Doing 37 to 40 there on page 95. It's your exam, don't worry. Just jump into the end of the course. It's not really your exam, I lied. All right, number 37. What did you write for a discriminant of 16, Maddie? Distinct. 2 real, rational, distinct roots. The main word I'm looking for there is rational, though. That's the key word. Number 38. What did you write for a discriminant of 7, Kendall?
2 real, irrational, distinct.
Good. 2 real, irrational, distinct roots. Again, the key word I'm looking for there is irrational. What about number 39, Brandon?
Two real irrational distinct roots.
Same exact answers as you had on 38, because they're both irrational values. You can't take the square root of 7 or 13. And number 40 is kind of the weird one, Genesis.
Two real rational coincident.
Two real rational coincident roots. Good. Perfect on those? Turn the page, and we're not going to go through this. Obviously, all of these are going to have two distinct roots, no coincident roots here. Also, no negatives, so no imaginary roots, right? On 41 to 44, which of those will be irrational, class?
41 and 42.
And therefore, 43 and 44 would be
Rational.
rational, right? Which means nice, easy numbers as opposed to things that will still have square roots in them. If you would go ahead and have it in your notes, I want to kind of break this down for you, kind of a recap of solving quadratic equations here. Two types of quadratics, right? You got your incomplete and your complete. Incomplete, super easy. Has an x squared, doesn't have x to the first. We always, class, isolate the x squared and solve by taking the square root. Always the same way. It's your complete that you have different options. So on a complete quadratic, if the a value is a 1, meaning it starts off looking easy, I probably don't use the formula, because probably there's a couple other ways to go. If the b is even, so you can take half and square, and you've got to see that you really didn't want to factor anyway, completing the square will always work. If the b is odd, and you say, I don't want to cut that in half and make a fraction and then square that and make a mess of things, no. Then I would suggest try factoring. Why do I say try factoring? It might not work. What do you do if it doesn't factor? I would use the formula. I would not complete the square, again, because you're going to make weird fractions. So I would kind of draw another arrow that comes back to here. But anytime in my mind, if the a isn't a 1, instead of, because that's the time where factoring is more trial and error, right? Just going back to the first test, when you start with a leading coefficient, it makes the factoring harder. I'm not even going to waste my time factoring. I see a number here. Maybe it factors, maybe it doesn't. I don't care. I go to the formula because I feel like it's going to be quicker. That's my personal take. Now again, if you can see the factors quickly, for instance, we did a problem for homework with the 5x squared plus 7x plus 2. I'm seeing that 5 and 2. I'm like, I'm pretty sure I can make a 7 out of a 5 and 2. Okay, maybe there I do go factoring. And there. But the reason I give this to you, to kind of jot down if you wanted to in your notes, is because now it's on you. Okay? We've been kind of, this is what you do. Do it this way. Do it that way. Now it's up to you. You're going to have to make an intelligent decision of how you want to solve, and these are my recommendations. Let's go ahead and work on a handout. If you're watching on YouTube, it's in the description. There are 2 handouts in the description of the video. Make sure you take the one that says for classwork. Your child should complete this handout. Take the classwork one now. 5 quick questions for you. I want you to solve this without looking up. Do those, or 4 quick questions for you. I can't count. 4 quick questions for you. Solve these without looking up, and then I want you to work through those 5 problems. So take a few minutes to work on the handout. Answer the 4 questions without looking up. And then if you need to refer to some of the other information up here, certainly can. For 5 through 9. I'm going to take this back off the screen so I can show the posters instead. In every problem, your first question you ask, is this complete or incomplete? Depending on your answer, determines how you proceed. The incomplete, isolate. Complete, maybe you factor, maybe you complete the square, maybe you just use the formula. Abby is finished. Brandon is finished. Michael's finished. About another minute and a half or so. About a minute and a half or so to be finishing up, and then we'll go over the answers together. Audrey's finished. Kendall's finished. Brecken's like, I've been finished. Yeah, you paused the video. That's cheating. I was done before Abby, just saying. Kevin's like, I didn't pause the video. No, you set it to half speed. All right, let's go and take a look at our answers here. Number one, how many roots or answers does each quadratic have, class? 2. What is the key to solving incomplete quadratics, class? Isolate the x squared. Number 3, is that a complete or an incomplete quadratic? Complete quadratic. What is A, by the way, in number 3, class?
-7.
5. What is B, class? B?
14.
-14. But you won't see that if you don't set it equal to 0 first, will you? What's the C? -7. Do you see why you need to get it in this form? Because if you just try to go off of, oh, it's 5 is A, C, B is 7, and C is 14. No, you're like, oh, I got it. The B is the 14. Well, actually, if you moved it over, it'd be a -14. So make sure we set it equal to 0. So we could use the quadratic formula, for instance, which hopefully you wrote out this, hopefully without looking. Negative B plus or minus the square root of B squared minus 4AC all over 2A. How many have the quadratic formula memorized? No problem. You're ready to go. Excellent. Good. Number 5, complete or incomplete, class? Incomplete. So what do I got to do? Isolate the x squared. We'll come back to that one in a minute. Number 6, complete or incomplete? Complete. It looks nasty. I don't see a way for 5 and 3 to give me a 7. So probably we should use the formula. Probably quadratic formula. Number 7, complete or incomplete? Complete. Looks like some nice easy numbers, right? And I definitely don't want to complete the square because I got an odd B. So probably do that one by factoring. Number 8, complete or incomplete? Complete. 128 is kind of big to try to factor, and I've got the even B anyway, right? So probably completing the square would be our best option on number 8. Again, would formula work? Yes. Would factoring work? Maybe so. Number 9, complete or incomplete? Complete, but you notice it's missing the C. Now I could do a C of 0, which would basically knock this out right here, or whenever it's missing the C, how would you factor it? Common factor, right? And that's really easy to do. So I would recommend number 9 using the factoring method there rather than the formula. And certainly we wouldn't want to complete the square. That's just, unless you divided a 3 out, I guess, then you could complete the square. How many followed basically what I recommended? As I was talking through, like, okay, yeah, that's what I did. All right, questions on any of the whys? Because again, my intent is you'd be able to be fast and efficient. Any questions on 5 through 9? Why would you approach it that way? All right, let's see how we did as far as the answers go. Number 5, we want to combine like terms first to get, Michael.
You get 6x equals
6x squared, right?
Yeah, 6x squared equals 30.
There we go. Combine like terms to get 6x squared. Kick out the 6 as a positive to get 30. Then
you divide away the 6
to get x squared equals
5.
And then, of course, we just take the square root to get x is equal to
Positive negative square root of 5.
How many have these two answers for number 5? All right, questions on 5. All right, number 6. We said formula here. What is A in number 6, class? 3. What is B? -7. What is C?
-5.
Positive 5. That has to move over and set equal to 0 first. And when your -5 comes over, it becomes a positive 5.
It's a positive 5.
Did I change what you had on your paper?
Probably.
How about that? All right, never mind. My paper has a -5 on there. Okay, that's what okay, I saw the +5, but I assumed that meant I'd moved it over to make it a positive 5. Never mind. I'd apparently changed it to be a positive 5 that comes over as a -5. Okay, I need a new answer key. All right, we're going to make a new answer key that doesn't confuse me. All right, so We've got our formula negative b plus or minus the square root of b squared minus 4ac all over 2a. And for the negative b, let's go to Genesis.
7.
Plus or minus the square root of b squared
49.
minus, and be careful here, 4 times a times c
Negative 60.
negative 60. Good. All over 2a.
6.
But the minus negative again is going to become a plus. And I had to make sure I have the correct version of that handout uploaded to YouTube too, by the way. Anyway, oops. So we add the 49 and the 60, and we get class 109 and 7 plus or minus the square root of 109 all over 6. I don't think that's divisible by anything. I think we leave it that way. Yeah, that's what I have on my answer key once I changed it or whatever. How many of these two answers? All right, questions. All right, yeah. That was. Make sure I got the correct thing here. Okay, so number 7, we said we want to solve by the factoring method. And to use the factoring method, like the formula, it's got to be equal to 0 first, Maddie. All right, so we get 24 over as a negative to get x squared negative 5x negative 24. From here we factored to get. And what were our two answers? Negative 3, positive 8. How many had those for number 7? Questions on that? Number 8. There's just too many ways to split up the 128. But if we complete the square, we don't even have to set equal to 0. Instead, we've got it equal to the 128 already. We just got to put a number on both sides. What number, Audrey?
16.
We have to get 4 and square to get 16. And we add that to both sides. Of course, the trinomial that we have in your class is special. It's a PSD, perfect square trinomial, which factors into a what binomial squared, Audrey?
X minus 4.
And then on the other side, we should just combine to get.
144.
Does this side have to have a square class? No. If it's not a square, we'll just get some irrational answers. That's okay. But it's nice when it's a square because it makes it easier to take the square root of both sides. Now we have.
X minus 4 equals positive negative 12.
And then as our final step, Brandon, we simply move over the.
Negative 4 to positive.
And we end up with x is equal to.
Negative 8 and 16.
Negative 8, positive 16. How many have those two answers? On number 8. Questions on that one? And we use the factoring method for that one. Okay, some of you were able to figure out the 8 times 16. And then number 9, really easy. Just factor out the 3x. Don't divide it away because you can't divide a variable away, but factor out the 3x to leave us with what in parentheses, Abby?
X negative 4.
And of course, we'll set each of these factors equal to 0 to get what? 2 answers.
4 and 0.
4 and 0. How many have those two answers on the last one? Those who made it that far. All right, questions at all on the handout? Any questions on solving quadratic equations? All right, clear your desk except for a clean sheet of paper, pencil, and calculator. Clean sheet of paper, pencil, and calculator. Sorry, YouTube people, there's the back half of the last problem we worked. And now it's gone again. All right, first last name at the top of your paper along with today's date, which is 11/2/21. 11/2/21 today's date. 11/2/21 today's date. And this is quiz 14, I believe. I feel like the last one was lucky number 13, so this was 14. If you're watching on YouTube, your homework is another handout that you see in the description of the video. So I'm going to end the video after the quiz. Obviously, students in here, I will give you the handout after the quiz as we dismiss. One more. Let's take a look at the quiz together now that everyone has one. Numbers 1 through 5. Pretty straightforward. Answer the questions. Numbers 6 through 10, solve. You use whatever method you want to on 6 through 10. Work carefully, work accurately. I have about 10 minutes for this quiz. You may begin.